The first proof that you had for homework was problem number 18. I already have the picture drawn. There were three givens: xy equals xz, yo bisects angle xyz, and zo bisects angle xzy. Now, while a lot of people like to start with whatever the first given is, I think in this case it's best to start with the bisector ones and turn those into equations first. So we're going to start, sorry about that, with yo bisects angle xyz, and zo bisects xzy. Now with the bisector, we had our choice between two different things. We could either state that the two pieces had to be equal to each other, or we could state that just the one piece was half of the entire angle, which is actually the course that we want to use right now, because what we're trying to prove is we want to connect the larger triangle to the smaller triangle. So that's what we want to do. We want to say that because yo, let me mark that, bisects angle xyz, we know that angle 2 is half of xyz. So angle 2 equals half of angle xyz. We're going to do the same thing for the other given. Since zo bisects angle xzy, angle 3 has to be half of angle xzy. And the reason for that is angle bisector theorem. Okay, the definition would say that the two halves are equal, but here we're saying that the one piece is half of the entire thing. So that's the theorem. Step 3. Now we're going to go back to that other given where xy was equal to xz. Based on that information, we're using the larger triangle as our isosceles triangle. So if xy is equal to xz, then angle xyz is equal to angle xzy by the isosceles triangle theorem. That's very similar to what we have in step 2. They both have xyz and they both have xzy. There's one slight difference though. In step number 2 they have 1/2. In step number 4 they don't. So I want to get the 1/2 in there. All I'm going to do is multiply each side by 1/2. So I have 1/2 xyz equals 1/2 xzy by multiplication property. We haven't used that one a lot, but this is really the only way that we use multiplication, is either to multiply by 2 or multiply by a half. Sometimes there's a 1/3 involved, but not often. Now, if angle 2 is equal to 1/2 xyz, I can substitute angle 2 in there. And if angle 3 is equal to 1/2 xzy, I can substitute angle 3 in there. So that's the substitution property. And my last step now, if angle 2 is equal to angle 3, I can work with that smaller triangle, OYZ. And if you look at that, that's an isosceles triangle now too, because angle 2 is equal to angle 3. So I can use the isosceles triangle theorem again to say that, what are we trying to prove here? Sorry guys. YO is equal to ZO by the isosceles triangle theorem.